Have you ever had that thought, what if the universe, deep down, is just code? Information? Well, today we're diving into a really wild theory that says exactly that. It suggests that reality, everything we see, isn't built from tiny little particles, but from a single, stunningly beautiful geometric object. I mean, think about it. What if all the big mysteries of physics, the tiniest particles, the fundamental forces that hold everything together, what if they're all just different ways of saying the same thing, just in a geometric language? That's what this theory is all about. It basically turns physics into this epic code-breaking mission. And to crack any code, you've got to start somewhere, right? So let's start with two of the toughest, most stubborn puzzles in all of physics. Okay, puzzle number one. It's a simple number, really. 3. See, the standard model, our current rulebook for physics, says a proton, and these things are in every atom that makes you up, is made of 3 even smaller things called quarks. Simple enough, but why 3? Why not 2 or 4? And here's the really weird part. Why can we never, ever manage to pull one out all by itself? All right, puzzle number 2 is, well, it's way stranger. It's this number, 137.036. This magic number basically sets the volume knob for electromagnetism for the entire universe. I mean, if you could just reach out and turn that dial even a tiny, tiny bit, poof, atoms would fall apart, stars would go out, the whole show would be over. Now, physicists have measured this number with just insane precision, but for the life of them, nobody knows why it's that number. It just is. So you can imagine, any theory that could explain both of these mysteries from the ground up, man, that would be an absolute game changer. And that's where this new idea comes crashing in. It says the blueprint for all of reality is a crystal. But hold on, we're not talking about a crystal made of atoms or anything like that. We're talking about a crystal of pure, raw geometry. And from this one thing, space, time, and all the particles, they just emerge. Okay, so this isn't your average crystal. It's something special called a quasi-crystal. The easiest way to think about it is like tiling a floor, right? A normal crystal is like a bathroom floor, a simple checkerboard pattern that just repeats over and over, super predictable. A quasi-crystal, on the other hand, it has perfect order, but the pattern never, ever repeats. It's infinitely complex, but at the same time, it's perfectly structured. Wild, right? So where does this thing even come from? Well, the theory says it's basically a shadow. It's a projection from this perfect 8-dimensional crystal called the E8 lattice, cast down into our boring old 3-dimensional world. And before you start thinking about parallel universes, when we say 8 dimensions, it's really just a math thing. Think of it like 8 different directions you can move in. The E8 lattice is a legend in math. It's the most perfect, most efficient way to pack spheres together in 8D. And its symmetry is just breathtaking. Okay, so how in the world do you squish a perfect 8D object into our 3D space? The theory actually gives us a recipe. Step 1, you start with a 3D grid that's based on the symmetry of an icosahedron. Like a 20-sided die. That gives you the basic skeleton. Step 2, you space out the layers of that grid using the Fibonacci sequence. 1, 1, 2, 3, 5, 8, and so on. And what's amazing is that when you follow this specific recipe, you naturally get a 3D quasi-crystal that is a perfect shadow of that E8 lattice. It just pops out. All right, so we've got our geometric master key. Now let's go back to that first mystery, the proton and its 3 quarks. How does our key unlock that? Well, the answer this theory gives is it's as brilliant as it is shocking. So you've got this standard picture, right? 3 little marbles kind of glued together. Now look at the new idea. Forget the marbles. The proton isn't made of anything smaller. Instead, it's a single continuous thread of the quasi-crystal itself that's just been tied into a simple, stable knot. And this is where it gets really wild. The theory says that quarks aren't things. You can't point to one. They're just the points on the knot, the places where the strands cross over, where the geometric stress on the crystal is cranked up to the max. It's a total flip in how we think about it. We're going from a particle to a property of the geometry. And look how beautifully this all maps out. The 3 quarks? Boom, they're the 3 crossings on a basic trefoil knot. That old mystery about why you can never get a quark by itself? Solved. It's just basic knot logic. You can't just snip a crossing out of a knotted shoelace, right? What about charge? That's just which way the knot is twisted. Right-handed is positive, left-handed is negative. And mass? That's just the energy it takes to bend and hold the crystal in that knotted shape. It all just clicks. Okay, so the proton explanation is pretty darn cool. But can it do it again? Can it crack that second, much weirder puzzle, that magic number 137? The theory says absolutely, and it claims it can do it using nothing but the geometry of the crystal. It all kicks off with this little geometric problem. The basic building blocks of this crystal are tetrahedra. You know, those little four-sided pyramid shapes? Now, if you take 5 of them and try to pack them together around one edge, they almost fit perfectly, but they don't. There's this tiny, annoying little gap left over, just 7.36 degrees. It's a fundamental problem. You just can't perfectly fill 3D space with these shapes. So what does the universe do about this gap? The theory says that to close it and become stable, the fabric of the crystal has to twist. It's literally like forcing a zipper closed when the teeth don't line up. You have to apply some force, some torsion. And that tension, that fundamental twist that's required by the geometry, that is the electromagnetic force. Its strength isn't some random number. It's determined by the size of the gap it has to close. Okay, so how strong is this twist then? Well, remember how the crystal is built using things like the Fibonacci sequence? That means the golden ratio is baked into its DNA. Because of that, the theory predicts the value of this twist should be related to something called the golden angle. And when you run the numbers based on pure geometry, you get a prediction, 137.508. Now, let's look at the actual number we measure in labs. It's 137.036. I mean, just look at those two numbers. They are so ridiculously close. A prediction from pure geometry, from first principles, is less than 0.5% off from one of the most accurate measurements in all of human history. That's just mind-blowing. But okay, close isn't perfect. What about that tiny little difference? The theory actually has an explanation for that too. It's something called vacuum polarization. Here's the idea. Imagine you've got a magnet, but you surround it with a cloud of tiny iron filings. When you try to measure the magnet's strength from outside the cloud, the filings will react and kind of shield it, making it seem a little weaker than it really is. The theory says the crystal lattice does the exact same thing. It reacts to that geometric twist, creating this little screening effect that makes the force we observe just a tiny bit weaker. So the pure, raw geometric value is a little higher, but what we actually measure is a hair less. Okay, let's just recap for a second. This model explains the proton, and it explains a fundamental constant of the universe, all from geometry. So what's left? Well, the Holy Grail, the final boss. Can it unify all the fundamental forces of nature into one single, elegant picture? And here it is, the grand vision. The fundamental forces, they're not separate things at all anymore. They're just different kinds of stress on this one geometric object. Gravity, that's just the crystal being stretched or squashed. Electromagnetism, that's the crystal being twisted. And the strong force, the one that holds protons together, that's the insane amount of energy it takes to try and force one strand of the crystal through another. It's the geometric lock that keeps those knots tied. You know, for decades, physics has always looked out. We build these absolutely enormous experiments like the ice cube detector buried in the Antarctic ice, and we stare out at the most violent, faraway events in the cosmos, trying to figure out where particles come from. This theory just takes that whole approach and flips it completely upside down. It says, stop looking out there. The answers aren't in the stars. The origin of literally everything, particles, forces, the magic numbers of the universe, it's not out there somewhere. It's in here. It's woven into the very fabric, the fundamental geometric code of space itself. It's a huge, beautiful, and incredibly bold idea. And it leaves you with this one final, nagging question, doesn't it? If this is right, if reality really is a geometric code, then what other fundamental secrets of our universe aren't just random accidents? What other constants are just sitting there, written into the language of geometry, waiting for us to finally find the right key to decode them?